Assalamualaikum, my name is Muhammad Faiz Fahmi.
My name is Muhammad Dini bin Muhammad Nazmin.
My name is Nur Sofiana Billah binti Rahim.
My name is Melissa Amrina Chan binti Muhammad Ali Chan. We're doing question number 1. Explain the meaning of differentiation and what are the technique of differentiation. Meaning of differentiation, the process of finding the instantaneous rate of change of a function with respect to one of its variable. For example, when a balloon inflates, differentiation tells us how fast the radius or value is increasing at that moment. Technique of differentiation. The first rule is the constant. When you differentiate a constant like 7, the answer is always 0. The second one is linear rule. The linear rule is used when two variables have a consistent relationship. For example, if fx equals to ax plus b, then the derivative is simply the constant a. Third one, we have power rule. One of the most commonly used technique. If you have a function like x to the power of n, its derivative becomes n multiplied by x to the power of n minus 1. For example, differentiating x to the power of 4 gives 4x to the power of 3. The fourth one, we have chain rule. The chain rule is used for composite function, which means function inside of another function. If you have something like f gx, the derivative is the outer derivative multiplied by the inner derivative. The fifth rule is the product rule. The product rule is used when two functions are multiplied together. The derivative is first function times the derivative of the second plus second function times the derivative of the first. It is written as dy dx equals to 2u prime multiplied by v plus u multiplied by v prime. The sixth one, we have quotient rule. When one function is divided by another, we use the quotient rule. The seventh one is the sum and difference rule, which means when terms are added or subtract, you will differentiate each term separately. It makes long expression easier to handle by breaking them down. The eighth one, we have implicit differentiation. Implicit differentiation is used when variables are mixed together in an equation like x squared plus y squared equals to 25. In this case, we differentiate both sides with respect to x, and anytime we differentiate a y term, we multiply it by dy over dx. The ninth one, we have linear approximation. And last but not least, we have derivative of trigonometric, exponential, and logarithmic function. In conclusion, differentiation helps us understand how things change instantly. With techniques like the power rule, product rule, chain rule, and others, we can find derivative quickly and accurately. These two make solving calculus problem much easier.
I will be guiding you through topic 2, which focus on the product rule and the quantity rule in derivative of trigonometry, exponential, and logarithm functions.
Before we get to the question, let us know first about the meaning of the product rule and the quantity rule. The product rule is used when a function is formed by multiplying two separate functions. For example, fx equals to us multiplied vx. The formula product rule is dy over dx equal to uv prime plus vu prime. The quantity rule is used when a function is written as one function divided by another, like u equal to us divided vx. The formula quantity rule is dy over dx equal to vu prime minus uv prime over v power of 2. Find dy over dx for the following function. A y equal to 9e power of x multiply tangent x minus 3. B y equal to x power of 2 plus 1 over sine x. Find the derivative of function u and function v. U prime equal to 9x power of x and v prime equal to z power of 2 x minus 3. Find the formula for product rule. Dy over dx equal to uv prime plus vu prime. Then apply to the formula. So we get dy over dx equal to 9x power of x multiply z power of 2x minus 3 plus 10x minus 3 multiply 9x power of 2. And then we expand and simplify. The answer is dy over dx equal to 9x power of x bracket z power of x at minus 3 plus 10 at minus 3 bracket. First, we find the derivative of function u and function v. So we have to write the formula for quantity rule. Dy over dx equal to vu prime minus uv prime over v power of 2. Then we apply to the formula, so we get dy over dx equal to sin x multiply 2x minus x power of 2 minus 1 multiply cos x over sin x power of 2. Then we expand and simplify it. So final answer is dy over dx equal to 2x sin x minus x power of 2 plus 1 cos x sin x power of 2.
Hi, I'm Dini. Today I'm going to presenting question 3, implicit differentiation. Implicit differentiation is technique used to find the derivative of function where the variables are mixed together and cannot be easily separated into an explicit form such as y equal to fx. Instead of rewriting the equation to x and y, we differentiate both sides with respect to x, treating y as a function of x. This means every time we differentiate y, we include the term y prime. This method allows us to compute the derivative of more complex relationship between x and y that cannot be expressed directly. The problem given is ln y plus sin square plus x square plus e to the power of y equal to 5xy. Find the dy dx using implicit differentiation. First step to solve this is we need to differentiate both sides with respect to x. So we need to differentiate the first function, which is ln y. When we differentiate the first function, we'll get 1 divided by y times y prime. Then we differentiate the second function, which is sin square plus x square plus e to the power of y. So we need to use the chain rule. Then we differentiate the sin to the cos x, then we differentiate the inner function. Then we differentiate the 5xy using the product rule. So in this case, u equal to 5x while v equals to y. So this is the equation after we differentiate both sides. The second step is collecting all terms containing y prime on one side. So any function that contains y prime, we will make it to the left, while no y prime will let it to the right. So this is the function after we collecting all the term of y prime on one side. The next step is we need to factor out y prime for solve the y prime. So this is the equation after we factorize the y prime. Lastly, we divide both sides by the equation that with the y prime to cancel the y prime. So then we can rewrite the equation to isolate y prime. So the final answer will be this equation. For conclusion, using implicit differentiation, we successfully found the derivative of an equation where x and y cannot be easily separated. By differentiating both sides with respect to x, applying the chain rule for term involving y and solving for y prime, we obtain the derivative in terms of both x and y.
Assalamualaikum, my name is Muhammad Faiz Fahmi bin Muhammad Zabri. I will present the last topic. The topic is linear approximation. Linear approximation is the method used to estimate the value of function near a point where the function is easy to compute. The idea is the differentiable function is a tangent line, so we replace the function with equation of its tangent line to get an approximate value. The problem is use linear approximation to estimate the value of 8.02 square minus 3 square root 8.02, correct to 2 decimal place. The problem is we need to find value by using the linear approximation. All question of linear approximation has the same step to solve it, so let's get solve this problem. First of all, we need to write a formula first. Remember the formula is fa plus f prime a multiplied delta s. Show that x is a new value or given value and a is an initial value or chosen value, and we can get value of delta x by x minus a. The second step, we need to identify the function. Looking to formula, we need to find fs and f prime x. So how to do this? We have to replace value in question x to get the function fs. After that, we have to find f prime x using a differentiation. 2 multiplied with x squared minus 1, 1 over 3 multiplied with x, 3 square root minus 1, and we get function of f prime x. The third step, we need to find value of s, a, and delta s. Let's find the value of x first. We can get a new value or given value on the question. So x is equal 8.02. Now how can we get a value of a? The initial value is the value of x that has belonged to the nearest whole number. We can round 8.02 to get a new value of a. So value of a is 8.00. Lastly, we need to find value of delta x. Looking for formula, it's a x minus a. So the value of delta x is 8.002 minus 8 equal 0.02. The last step, we can apply all function f value into the formula. First, we apply the function fs and f prime x. Now, we can replace x with the value of a and delta x with the given value. After apply the value, we can calculate as usual to get a solid answer. Don't forget the final answer need to be 2 decimal place. Finally, the final answer we get is 62.32. In conclusion, linear approximation is a quick way to estimate a value using a nearby point. It makes hard calculation easier by using a simple straight line estimate. And this is all our reference. Thank you.